Hi, everybody. Happy Friday. So this week we don't have any homework or quiz due. So today we will finish 8.1 and we will start 8.2. And then your homework about 8.1 and 8.2 is due next Friday. And you also have a quiz next Friday based on the 8.1 and 8.2 stuff. Okay? So let's continue. So by the way, I give you back your exam. Make sure you do the exam corrections and fill out the exam wrapper and submit it in Canvas. Okay. So for your midterm grade, I will look at your scores in Canvas and then post your midterm grades. So if you check your homework scores. If you don't get perfect homework scores, like which problem you don't understand, please come to see me. Okay, so increase your homework scores. And also the self-assessment includes the practice exam one. So if you miss some points about the practice exam one, maybe you forgot to include the estimated total score, or maybe you forgot to make corrections, then you can resubmit to get the points back. Okay, so the practice exams and also exam correction and wrapper, which is due next week. So the solution of the exam I posted on the course website. So you look at the solution and write down the correction next to your mistakes. Exam correction is 5 points. Exam wrapper is 5 points. So exam wrapper is like a survey. It's 2-page survey. It asks you how did you study for your exam. Okay, so yeah, exam correction and wrapper is right here. So you're gonna upload 2 files. One is the exam correction. So you make the correction next to your mistake in red color pen or other color pen, so I can distinguish with your work and the correction. After you finish, take pictures, combine into a PDF, and then upload here. The exam wrapper is this link. It's a 2-page survey. It asks you how you study for the exam and how will you do differently, and how can I help you. Okay, so exam wrapper is worth 5 points. And also, by the way, when you submit image, please submit JPG files. Do not submit HEIC files because Canvas does not open HEIC files. So if you have iPhone, yeah, me too. When you can change your camera setting, so you take pictures, it's not so high quality HEIC. It could be JPG. Okay, everybody? All right. So let's continue. So section 8.1, we talk about sine graph and cosine graphs. The graphs look like waves, right? Sine start with 0 and go up and down, right? And cosine start with 1, go down and up. Yes, everybody? And you can see the applications of sine, cosine graph in many different ways. So, for example, like this application problem. The learner's eye is a huge fairy wheel with a diameter. So you have played something like this before, right? In a park or Disneyland or some places, okay? Another applications is like wave, water wave or light wave, okay? They're like sine, cosine function. And another is circuits, electricity, okay? So you might not have any electrical engineering major. The circuits, they're also wave. And how about spring? Have you played with spring? So if you have a spring and then you pull your spring down and release, what happens? Yeah, it bounces up and down, right? So All these are gonna relate to sine or cosine graph. Okay, so let's look at this problem. So this London eye has a diameter of 135 meters. So by the way, the Europe used meter system. So we use meters for the length and kilograms for the weight. So the diameter, D for diameter, is 135 meters. It completes one rotation every 30 minutes. Okay, so one rotations every 30 minutes. Riders board from a platform 2 meters above the ground. So if this is the ground, then the rider board is 2 meters above the ground. Express a rider's height above the ground as a function of time in minutes. So we know the height is going to be oscillating, right? And this becomes sine graph or cosine graph. So the standard form of a sine graph is A sine bx plus c plus d. Yes, everybody? This is a standard form of a sine graph. And could you tell me what is A? What is the coefficient of the sine function? It's the amplitude. Okay. It's not entirely the 135. It's
the radius.
Yeah, the radius. Exactly. So A is the amplitude. Okay, and is half of the diameter. So 135 over 2. Oh, what is that? 67.5. Yes, everybody? So the radius is diameter divided by 2. So we got 67.5. So you can imagine this is like the center. Okay, so this is like the center. Or you can say is the midline. Okay, we go up and down away from the midline, 67.5. That's the amplitude. Is that okay, everybody? Now, how about B? What is B? B is related to the period. Right, everybody? B is related to the period.
135.
Huh?
135.
135 it affects the amplitude, but the period is the horizontal distance. It's about one rotation every 30 minutes. So which means it's here, and then after 1 minute, it goes back to this spot.
180.
So, okay. One rotation. So period. Okay. So period. One rotation every 30 minutes. So period is 30 minutes. Oh, okay. Yes, today is Friday, the 6th week Friday. Okay, so period is 30 minutes. So now the time is a minute. Okay, so imagine the graph. The graph, our x is like the time. Okay, maybe I can say here, x is like the time in minutes. Okay, and you have a graph here, and y is gonna be the height above the ground. Okay, so you have your x and the y. You Usually people use T for the independent variable if it's the time. So we can change the x to t. Okay, we can change the x to t, and t is stand for time. Okay, period is 30 minutes. Yes, everybody? And period is related to B. If you can remember, period is 2 pi over the coefficient of x, but our variable here is t. So coefficient of t in the angle, which is B in this case. Is that okay, everybody? When I give you the standard form and ask you to find the period, then you use the period of sine x, which is 2 pi, over the coefficient of x in the angle or argument. So that's why it's the B. So 2 pi over B is 30 minutes. How do you find B? So what do we do? Multiply by, multiply B on both sides. So multiply by B, so B cancel. And then what do we do? Yes, now we divide 30 on both sides. We get B is 2 pi over 30. Yeah? Can we simplify? What is 2 pi over 30? Yes, so it's pi over 15. Is that okay, everybody? Yeah, so take notes. Don't play with your phone. Okay, so you use your phone either to calculate or take pictures, but don't use your phone for other stuff. Okay, let's see. That is the B. So we figure out the A, we figure out the B. The C, let's take care of that later. D is the what? What is D?
10 plus 2 plus the 2 meters off the ground.
Yes, and that is the midline, right? Is you shift the sine graph up by d units. That is the midline. So midline usually is y equals to d, but in this case, look at your midline. It's 2 plus 67.5 exactly. Yeah, very good. So 67.5 plus 2 is 69.5. Right? So we figure out all the things except C. Now let's rewrite it. So y equals A is 67.5. And then sine B is pi over 15. T plus C we don't know yet. And then D is 69.5. Is that okay, everybody? Okay, so now C is about the phase shift. Okay, you want to shift your sine graph to the left or to the right by C over B unit. Okay, that's the phase shift. In this case, we need some information to help us to find the C. So imagine you write this very well. Okay, which point do you start? The bottom, right, everybody? So we need some information here. Y of 0 is the bottom. What's the height of the bottom? 2. Exactly. We're on the writer's board. So y of 0 equals to 2. Thank you. So we can use this information to help us find C. Let me make sure and everybody understand up to this part. So we just missed the C. And in order to find the C, we need to use the information. You start with the writer's board, right? You don't start in the sky, yeah? We start in the writer's board. The y of 0 equals 2. Now we plug in. This means we plug in y is 2 and the t is
Zero.
0. So 2 equals 67.5 sine t is 0. So we get 0 plus c plus 69.5. So far, so good, everybody? How do we find the c?
Question.
Yes.
So how do you know that 0 is t?
Oh, because here. At the beginning,
okay.
you start with
Okay.
the lowest points. Yes. At the beginning means the time is 0. Yes. So we plug in t is 0 and y is 2. And we want to solve a c. So we want to isolate the sign expression. Okay? Isolate means you don't want to see the 69.5, you don't want to see the 67.5. So what do?
Right, 69.5.
Yeah, subtract 69.5. And then we get what? What's on the left? Yeah, minus 67.5 equals 67.5 sine C. And then what do? We divide. Yeah, we divide 67.5. Oops. And do you see what happened? Yeah, sine C is minus 1. Let's wait until everybody gets to this step. So we know our A, we know our B. Like A related to the amplitude, and B related to the period, right? And the D is the midline, right? So after we plug in all those numbers, and we use the information y of 0 equals to 2, we plug in, we want to find C. Now we get sine C is minus 1. Here's the place you need the graph of sine. Okay, what's the graph of sine? Yeah, it start with 0 and go up and down, right? And we know the period is 2 pi. So this is pi over 2. And this is 3 pi over 2. And this is minus 1. So be familiar. This chapter, the most important things. Be familiar with all the trig graphs. So 8.1, we learned sine and cosine. Those 5 key points, keep those in mind. Now look at the picture. Here you see the C is the input. The output is minus 1. So you're asking when the Y, the output, okay? So when the Y is minus 1, what is the input? Yeah, you see from the graph, we get C is 3 pi over 2. By the way, you have infinitely many answers because this is 2 pi periodic. Instead of this value, you can say what? You can say this is minus pi over 2, or Maybe you can go to that side. You can say it's pi over 2 plus 2 pi. There are so many different answers. Okay? So, but we usually just look at, from 0 to 2 pi to pick a value. Therefore, we can get y is 67.5 sine pi over 15t plus c is 3 pi over 2 and plus d is 69.5. This is just one way to express the height. There are many different ways. For example, your c could be add constant multiple of 2 pi or subtract multiple of 2 pi. Then you get another function. And furthermore, okay, so we mark instead of using sine, you can also use cosine. Okay, so we mark there are more answers. Okay, so your C, you can get this number plus or minus constant times 2 pi, then you get a different answer. Are you okay with this expression? Plus or minus multiple of 2 pi. Okay, n is any integer. So multiple of 2 pi. Or we can use cosine instead of sine. Okay, so if you use cosine, let me write it down the answer. If you use cosine, you get the answer is minus 67.5 cosine pi over 15t and plus 69.5. Okay, so you can play with that and show why we get this answer. If you want to see this, sorry, maybe make it bigger. Okay. Think about what's the cosine graph. Cosine graph is like wave. It starts with what? Yeah, it starts with 1 like this. And look at the negative. So this is cosine x. But what did the negative do? Reflect over the x-axis. Exactly. Then it goes like this. That's why exactly here we don't need any phase shift. We just need a minus sign in front of it. Then it will get your negative cosine graph will start with the lowest point, which is what we want. Okay? And you see the amplitude remain the same, the midline remain the same, the period remain the same. It's just the C part disappeared because the cosines you used to start with the highest point, but you multiply by -1, it starts with the lowest point. We don't need to shift horizontally. Okay, everybody? Yes. So this is one application problem. Any questions about this problem? Yes.
Are we just solving for every value like A, B, C?
Yes.
Okay.
Yes. So this problem, it gives you the information. It asks you to find the function to describe the height above the graph. Yes. So we make a function. And there are so many different answers. You just need to pick one. Okay, so you're free to use sine or you're free to use cosine. Yeah. Okay, so this is 8.1. Let's close that and let's look at 8.2. Okay, so 8.1, we study the sine and cosine graph, and 8.2, we're gonna study the remaining. So the remaining is tangent, cotangent, secant, and cosecant. Okay, so when we draw the graph of tangent, we look at the values. Instead of these numbers, I want you to look at different numbers. Okay, let's write it here. Okay, so we have x and tangent x. So 5 key points. They are minus pi over 2, minus pi over 4, and 0. Then pi over 4, and then pi over 2. Okay, I hope you still have the formula sheets of, let me see. Okay, chapter 8. Yeah, take it out. So yeah, these formulas, fill those out at home. And then we fill out a sine and cosine graph. Yes, everybody? So now we fill out the tangent graph. So 5 key points again. Minus pi over 2, minus pi over 4, 0, pi over 4, and pi over 2. So I have one extra copy. So who didn't get a copy before? Okay, I only have one, so this goes to, okay. So by the way, you can find these sheets on our course website. Here, this is a formula sheet chapter 8 blank. So in the exam, I will print out the blank formula sheet so you can fill those out first and then continue to work on your exam. If you feel that it's easier. Okay, now let's see here. So 0, okay, at 0, tangent 0 is 0. And then pi over 4. Do you still remember what is tangent pi over 4? If you can remember. Here. Yeah, 1. Yes, everybody. Because sine pi over 4 is root 2 over 2. And cosine pi over 4 is root 2 over 2. They're the same number. Tangent is sine over cosine. They cancel, so you get 1. Yes, everybody? So suggest you fill out those values. Okay, so we get 1. How about pi over 2? Pi over 2, what happened? Okay, let me find the, okay, these yeah, it's undefined. Yes. Good. So remember this? You filled those out before. Hey, pi over 2, undefined. Yes. So this is undefined. Okay. Yes, everybody? And furthermore, so when you connect those points, it looks like this. Okay. How about on the other side? Okay. Do you still remember that tangent negative theta is negative tangent theta? Do you remember the negative angle values? Well, cosine and secant eat the minus sign. Yes, everybody? So tangent does not eat the minus sign. You can put the minus sign in front of the tangent function. Do you still remember that, everybody? Aha! That's why the tangent negative pi over 4. So tangent negative pi over 4 is negative tangent pi over 4. Yes, everybody? Which is negative, what's tangent pi over 4? Yeah, it's negative 1. So when you put, minus pi over 4, we get negative 1. And then here, negative pi over 2. What happened? If tangent pi over 2 is undefined, the tangent negative pi over 2 is negative tangent pi over 2, which is also undefined. Okay, so that's why you put the dash line here. And when you connect the point, it looks like this. Is that okay, everybody? So the shape looks like a x cube. Okay, but yeah, do you feel it looks like an x cube? But the tangent function is a periodic function. So you have so many copies of this graph. Okay, so let's write it down. The values: undefined, -1, 0, 1, and undefined. Easy to remember? Yeah, undefined. No values. -1, 0, 1, undefined. You see all those 5 key points, the y values, they're just either 0, either 1, either -1, either undefined. Okay, so not very hard numbers. Just remember the graph, the shape of the graph. Oh, and then you can see. Okay, so everybody finish this graph on this sheet? Okay, let's come back. Okay, come back here. So we look at the 0, the pi over 4, the pi over 2, and we know pi over 4 is here, and 1 is here. Let me use orange color, maybe that's better. And the pi over 2 dashed line. 0, 0. Minus pi over 4, -1. And then the pi over 2, dash line. And then when you connect them, you get this. So this is one period of the tangent graph. And if you continue and use the reference angle, you will see the following. The idea is just use sine divided by cosine, and then you can get all the other angles. Okay, but I want you to look deeper, okay? So zoom in and look deeper. Okay, look at the first quadrant. This is tangent, right? The common angles are 0. This is pi over 6. This is pi over 4. And what is this? Pi over pi over 6 here, smaller. Pi over 3, and then pi over 2, right? So look at the y values. So here, this part is going to be tangent. Pi over 6 is 1 over root 3. And here, pi over 3, you see here is some bigger number is square root of 3. So you can see the tangent graph is increasing. Okay, the pi over 6 smaller, the 1 over root 3 is smaller, and then pi over 4 is bigger, so 1 is bigger than this, and pi over 3 is bigger than pi over 4. Therefore, the y value is square root of 3. Do you know what square root of 3 is? 1 point. You have your calculator? Okay, what is square root of 3? 1.732. Yes, 1.732. Okay? So you see it's above the 1. See? So that is the first quadrant. Okay, so that's the things we need to know. So this is 0. That is 1 over root 3. That's 1. That's root 3. And then that is undefined. Okay? These parts you gotta know. Okay? And then the other ones, you can just like copy and paste this graph here, here. So you have so many copies like this graph. Okay? Then you can find the values down the graph. Is that okay, everybody? Just imagine it looks like x cubed, but it's so many copies of x cubed. It's infinitely many copies of x cubed. Okay, and now you can see the domain. Domain is the set of inputs, the x values. Okay, maybe it's better to look at this picture, okay? Because we have so many copies, right? So look at this picture. And do you see we have vertical asymptote as pi over 2? Yeah? So x cannot be pi over 2. And also it cannot be negative pi over 2. And it cannot be 3 pi over 2. So x cannot be pi over 2 plus n pi, where n is integer. Okay, we have infinitely many vertical asymptotes. Is that okay, everybody? The undefined values shows the vertical asymptotes. So this is the domain. X cannot be pi over 2 plus n pi. Is that okay, everybody? Range. Look at the y values. What do you say? All numbers, exactly. So we can say it's minus infinity to infinity. Or we can say it's the set of all real numbers. Everybody okay with that? Okay, so let's see. The period here is pi. You see? What's the difference between pi over 2 and negative pi over 2? It's pi, right? So the period for tangent is pi. The graph is discontinuous. You remember continuous means you draw the graph without lifting the pencil from the paper. Yeah, here it's not connected. So it's discontinuous at the values pi over 2 plus n pi. And yeah, the x-intercept occurs at n pi. The x-intercepts are 0 because it's pi periodic. You can add multiple of pi or you subtract multiple of pi. That's why the x-intercept is n pi. And does it have any amplitude? No. Does it have any bands? No, it just goes forever on top and bottom. So no amplitude. Amplitude only happens when you have sine and cosine because it's bounded. Yes. So here, no extrema. It goes to infinity or minus infinity. And do you see this picture? It's symmetric with respect to the origin. Yes. So this is symmetric with respect to the origin. That's why it's an odd function. Okay. So tangent is an odd function. How about sine? Do you remember sine? The graph of sine, is it an odd function or even function? Odd. How about cosine? Even. Yes, very good. Okay. So that's the tangent. Now let's get to cotangent. What are the 5 key points? Okay, I have the 5 key points here already. So, oops. Okay, something wrong. Let me see. Can I draw it here? Okay. Yes, the 5 key points are 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay, so let's see. Okay, what is the graph? Okay. Cotangent. What's cotangent 0? Undefined. Cotangent pi over 4? 1. Cotangent pi over 2?
0.
Yeah. Okay, so let's see. Here we got undefined, and that is 1. That is 0. Yes, -1. Why? Okay. If you have the sine and cosine graph, okay? Let's see. 3 pi over 4. You can look at the sine graph like this, and the cosine graph like this. Okay, so we know this is pi over 2, this is pi over 2, that's pi, and that's pi, and 3 pi over 4 is here. Let me make it bigger. Okay, that's 3 pi over 4. Okay, do you see cotangent is cosine over sine? Do you see cosine is negative? Cosine 3 pi over 4 is negative root 2 over 2. And then divided by sine 3 pi over 4, which is root 2 over 2. So therefore you get minus 1, exactly. Okay. How about pi? Okay, you can see when x goes to pi, your cosine, do you see your cosine? So it's cosine over, so cotangent is cosine over sine. But when x goes to pi, you see the cosine is negative 1. Yeah, cosine is negative 1, but your sine is going to 0 from the positive side. Undefined. Yes, very good. Okay. So yeah, negative 1 over 0 is undefined. So that's why we have this. And you can plot this on the graph. So as 0 is undefined, we have a vertical asymptote. And pi over 4, we got 1. Pi over 2, 0. 3 pi over 4, we got negative 1. And a pi is asymptotes. And we connect them smoothly. This is one period of the cotangent graph. Is that okay, everybody? So everybody, move your hands. Tangent, like x cubed. Cotangent is the opposite, but you start with 0. Okay? Yes. So let's get back to this. Okay. Those special angles are 0, pi over 4, pi over 2, 3 pi over 4. Yes. Cotangent values. Exactly. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. We have vertical asymptotes. And 1, 0, and negative 1. And this is undefined. So we get the graph of cotangent. Yes. So this is so important. Remember those 5 key points for the tangent and cotangent. Okay? Everybody finish this part? Mm-hmm. Yes, okay. So let's see. Okay, so you can see from the graph of cotangent. Oh, I forgot to say the domain. Domain. What is the domain? X cannot be 0, pi, 2 pi, or negative pi. That is like, so x not equal to n pi, multiple of pi. How about the range? Your y values. Yeah, then infinity to infinity, the set of all real numbers. Yes. Okay, and what is the period? Yeah, period is the same as the period of tangent. It's pi. Uh-huh. And you see it's discontinuous at the x values and pi. That's the vertical asymptote. The x-intercepts are pi over 2 plus n pi. And it has no amplitude because it goes to infinity minus infinity. And look at the graph. It's a symmetric with respect to the y-axis or symmetric with respect to the origin? The y-axis? The origin. Yes. So it's an odd function or even function? Symmetric with respect to the y-axis is even. Symmetric with respect to the origin is odd function. Yes. Yeah. Mm-hmm. Very good. So like origin, see? So it's an R function. And I also want you to like go deeper and look at this. If you go deeper and look at this, this is pi over 6. This is pi over 3. Do you see a cotangent pi over 6 is going to be some number bigger than 1? That's square root of 3. And cotangent pi over 3 is some number smaller than 1. That is 1 over square root of 3. So keep that in mind. Okay? Those special angle values 0, pi over 6, pi over 4, pi over 3, and pi over 2. And the y values, root 3, 1, 1 over root 3. They're so important. Okay, everybody? So, we have little bit time. How about I ask you, okay, look at the graph. Can you tell me, so I have, okay, so this is cotangent. Oops. Something wrong here. Okay, so I want to ask cotangent, what angle give me negative root 3? Cotangent, what angle is negative root 3? Negative root 3 is some number bigger than, magnitude, some number bigger than 1 in magnitude. So it's somewhere like here. Do you agree? So you want to find the angle. You see? That's the y value. You want to find the angle. What is this angle? So this is what? This is pi over 6. This is pi over 3, pi over 2. And what is this? You see the difference is pi over 6. So this is pi over 6. And then this is 2 pi over 6, which is pi over 3. And then this is 3 pi over 6, which is pi over 2. And then this is 4 pi over 6, which is 2 pi over 3. Then this is 5 pi over 6. Okay, so we can use the graph to figure out the angle. So I can give you any y values, of course, common angle values. Then you can find the angles. By the way, this is just this angle. It could be this angle, right? If it's this angle, what is that? It's negative pi over 6. And how about this? This would be this angle at pi. Yes, everybody? So you can find more answers based on the picture. Yeah, let's continue next class. Have a nice weekend. Yes. Bye.